On October 31st, 2008, a person, or group of people depending on who you ask, named Satoshi Nakamoto released an email titled Bitcoin, Peer-to-Peer eCash Paper. Here, Nakamoto details why autonomous digital currencies haven't emerged in an age where the internet is widely available. Double spending. Double spending is when a transaction is sent twice, allowing for someone to send an amount greater than their balance. If someone double spends their full balance to another account they own, they could double their money, creating money from nothing, inflating currency, and undermining that financial system. Double spending is a problem unique to digital currencies. Paper and coins can't be cloned freely, and especially not in person at the moment of a transaction. But in a computer, files can be copied and inputs can be duplicated. So up until 2008, online transactions had to pass through a third party to prevent double spending, which meant an online transaction had a single point of failure. If that third party were to be hacked, the hacker creates for himself money from nothing. In the email sent that October, Nakamoto writes, "We propose a solution to the double spending problem using a peer-to-peer network. Transfers of digital currency would be verified by a distributed and decentralized network with multiple computers. Doing so, volunteers who receive payments and inflation for their service." The solution was previewed in the email and then detailed on the white paper linked inside for a software called Bitcoin. Over the next month and a half, Satoshi talked back and forth with his mailing list, answering concerns about the proposed infrastructure of Bitcoin. The currency is inflationary at about 35%. That's how much faster computer users get annually. The inflation rate of 35% is almost guaranteed by the technology. As computers get faster and the total computing power applied to the creating Bitcoins increases, the increase is proportionally to keep the total new production constant. Thus, it is known in advance how many new Bitcoins will be created every year. If the supply of money increases at the same rate the number of people using it increase, prices remain stable. If it does not increase as fast as the demand, there will be deflation and early holders of the money will see its value increase. January 8th, 2009, after the first week of the new year, approximately 70 days from the release of the white paper in the original email, Bitcoin version 0.1 was released. Nakamoto kept pushing updates to Bitcoin, including new features and bug fixes, and in 2010, the first Bitcoin exchange opened. Opening price set to $0.003. Today, Bitcoin sells for over $7,000, 10 years later, making it the major asset of the decade. Operating online publicly around the world, Bitcoin has stood the test of time as being an online financial system with an infrastructure yet to be compromised. What it took was inventing a new form of database to keep records and make updates with each transaction online.
You must take the A train if you go to Sugar Hill way up in Harlem. If you miss the A train, you'll find you miss the quickest way to go to Harlem. Hurry, get on now, it's coming. Listen to this razor humming over. Get on the A train. Soon you'll be in Sugar Hill way up in Harlem.
While the database technology was invented before the internet, the database technology behind Bitcoin was created from the ground up to include online connectivity as a core consideration for all parts of its infrastructure. When a transaction is made, this transaction is broadcast to all Bitcoin nodes on the network and verified by all nodes on a process called mining. As transactions are pushed to the network and distributed Bitcoin nodes stamp their verification, these transactions are organized into a block. Each block represents a period in time, and each block references the previous block, forming a history of all transactions in a chain of blocks. This technology is currently known as a blockchain. And the inspiration? Looking at Bitcoin and the references mentioned at the end of the Bitcoin white paper, Bitcoin as an innovation becomes demystified. From one perspective, there was no Satoshi vision, as Bitcoin was an implementation of the vision of Wei Dai, Nick Szabo, and other cryptographers before Satoshi Nakamoto created Bitcoin. From B-Money, the creation of money, anyone can create money by broadcasting the solution to previously unsolved computational problem. This process of creating money from broadcasting a solution to computational problem is proof of work model that Bitcoin miners use to run the Bitcoin network. BitGold states, Alice on her computer generates the proof of work string from the challenge bits using a benchmark function. The proof of work is securely timestamped. This should work in a distributed fashion with several different timestamp services so that no particular timestamp service needs to be substantially relied on. Nick Szabo introduced the term proof of work to currency, a term which was coined before BitGold but after B-Money. Wei's B-Money, which would be implemented with Bitcoin, was published in 1998. However, before B-Money, before BitGold, Nick Szabo had been writing papers fleshing out the idea of smart contracts. A smart contract, as Szabo puts it, allows the creation of binding agreements enforced by code. These contracts are embedded in software and hardware we interact with daily. The enforcement of a smart contract may be the transfer of value, ideal for use in digital currencies. A simple example Szabo used to describe these digital contracts are vending machines. The vending machine is a contract with a bearer. Anyone with coins can participate in the exchange with the vendor. The lockbox and other security mechanisms protect the stored coins and contacts from attackers, sufficiently to allow profitable deployment of vending machines in a wide variety of areas. And while smart contracts have been talked about in the Bitcoin developer community, no digital currency implementing a native smart contract platform had been created. That is, until a writer and developer known as Vitalik, in November in San Francisco, wrote the Ethereum white paper. Ethereum at the time was called Cryptocurrency 2.0. The vision was to create a platform that would become the next generation of the internet, a Web 3.0, allowing people to explore both a traditional and a decentralized web. New applications would be created called decentralized apps, which use Ethereum as its global operating system. Like BitTorrent content sharing system, Ethereum network nodes will run on thousands of computers around the world, and short of shutting the internet down, its operations cannot be halted. While Bitcoin served as a central bank of the internet, a protocol built for storing and transferring value, Ethereum served as the internet for a new digital economy. A protocol built for creating decentralized applications built on a programmable layer on top of the digital currency. Ethereum creates an entire subsection of software and internet founded on digital value instead of just information. Where previous iterations of the web dealt with sharing of information, Ethereum's Web 3.0 deals with intelligent financial transactions. Ethereum creates a finance-based internet. Today, Ethereum is the world's leading smart contract platform, being the world's leading programmable network ledger. And Ethereum hasn't reached finality yet. Its development, as the evolution of what blockchain will become, is undergoing. Over the coming years, Ethereum plans to transition into what is currently called Ethereum 2.0. Plans for ETH 2.0 divided by phase include the following. Phase 0, proof of stake, as how the network operates. Phase 1, introducing sharding to the network. Phase 2, smart contract infrastructure with the Ethereum 2 virtual machine. Phase 3, updated light clients with markets created for storage. Phase 4, cross-shard transactions. Phase 5, fork-free internally with tightly coupled shard infrastructure. Phase 6, updated shard spec with shards in shards recursively. And after Phase 6, Ethereum 3.0. When Phase 0 launches this year, Ethereum users will notice the following. First, there will be 2 Ethereum chains. Ethereum itself is being rebuilt from the ground up introducing significant changes even from the base protocol. This rollout of ETH2 will release in phases, and until the final phase is released, ETH1 will still exist fully featured. Once ETH2 matures, the first Ethereum chain, ETH1, will be phased out. Second, Ethereum 2 will start without smart contracts. Phase 0 of Ethereum 2 will only exist as a digital currency with no smart contract functionality. Smart contracts will be reintroduced in Phase 2. Third, when users look at Etherscan, they'll see latest slots rather than latest blocks. Slots are the result of the change to proof of stake. Currently, Ethereum works similar to Bitcoin. Transactions are confirmed through the network, agreeing a user is sending funds they own by using computing power, also known as mining. Mining by computer power consumes large amounts of energy collectively, leaving a significant carbon blueprint. Additionally, the hardware used to mine becomes outdated and loses worth, as has been with ASIC equipment. Proof of stake, the hardware required to validate using proof of work, may be that of a laptop, bringing potential large reductions to the carbon footprint of transaction validation. With ETH2, network agreement will be done with an economic algorithm rather than by computing power alone. A network validator deposits ETH, which can be taken away if they're discovered to be a malicious validator. For the validators running the network, if interest in ETH is generated and returned to them. New blocks are proposed by block proposers. A block proposer is a validator chosen to propose a block at a given time, meaning validators take turns being block proposers. The remaining validators check if the proposed block is valid, sending attestations or proof/evidence, and the proposed block is valid or invalid. If a proposed block is voted as invalid by the rest of the validators, that block isn't recorded, and that slot is skipped, omitting from the chain. Currently, ETH1 produces a block every 15 plus or minus 5 seconds, not considering the difficulty bomb. Every 15 seconds, a block will always be produced, roughly. In ETH2, a slot of time is where a new block can be produced, which means there can be slots without new blocks. The following phases are the introduction of shards. Sharding is a database concept. It's a separation of a database into multiple partitions, or the dividing of data into multiple locations. Sharding represents the majority of changes introduced in Ethereum 2.0 as it matures. With all these changes, what does remain is a blockchain, a ledger of transactions validated and stored through a network. A blockchain is a network ledger. The origins of network ledgers were the combination of two existing technologies, the database and peer-to-peer applications. The combination of these two things has created what today is a store of value and an economy of over 200 billion. A decade of existing, and this technology still has room to grow, appearing to be in its infancy.